in the life cycle of the sun's about in its midlife years, and so it'll eventually burn out. And so our overwhelmingly dependent source for everything on Earth is about halfway through its existence. And so in about 4 or 5 billion years, the sun will eventually become a red giant and essentially burn itself out soon after. And so you could say the sun is having a midlife crisis. I show this for two main reasons. First off, this is useful to understand perspective as far as how big Earth is to other things. But also, a student submitted this to me, and so anytime throughout the semester, if you have a way to showcase something or something you've come across prior, don't hesitate to send me, because I often will use it in a future semester. But this kind of gives you a perspective as far as how big Earth is relative to smaller planets in our solar system, although Pluto is not technically a planet anymore. Now, putting that in perspective, Earth compared to the other bigger planets in the solar system. Now, when we think about the sun relative to Earth, now we're just a little speck on the image here. And so think about how big the sun is, massive compared to the size of the Earth. And of course, our sun is just another star. If you think about it compared to other stars, it's actually quite small. So not only is our sun suffering a midlife crisis, it's also, maybe you could say, suffering from small man complex. So compared to other suns, other stars, very, very small. And now comparing to the biggest stars out there, the sun is just one pixel. If you can kind of see it over in the bottom left, it's just one pixel in this image. And so if you can think about our Earth compared to the sun, compared to the bigger stars out there in the universe. Very important slide here for maybe getting rid of maybe our preconceived notions about some things. First off, Earth's orbit. Earth orbits around the sun, and that average orbit is about an average distance of 93 million miles, so quite large. But one of the things is we see the word average, and so it's not something that's consistent. It doesn't stay the same the entire time during the course of its orbit. And so it's slightly elliptical. But this, very important, this elliptical orbit has very, very minimal influence on the changing of the seasons. And I showcase this using two key terms, perihelion and aphelion. First off, perihelion is the point in Earth's orbit around the sun in which it is closest to the sun. So the closest the sun will ever be to Earth is actually on January 3rd. And so this is about 91.5 million miles distance from Earth to Sun. However, by July 4th, the aphelion, the Earth is 94.5 million miles away. And I showcase this because you would think, January, that's when it's cold in Indiana. You would think that because the Earth is closer to the Sun, it should be warmer. And the opposite would be true for July 4th. And so the sun, although it's closer to the Earth, has no role in influencing temperature on Earth's surface. And so very important that this has Earth's orbit has no effect on temperature on Earth's surface. All right, I'll let you figure this one out. Which one is aphelion and which one is perihelion?